Awesome. Okay, well, good morning, everyone. Um, this is the second day of our faculty talks. So really excited to welcome Drs. May Hwang and Dr. David Kim today. They're going to be speaking about the research that they do at the St. Anthony Falls Laboratory. So we're really excited to have them join us today and taking the time to share their research with us. So please give them your attention and I'll go ahead and pass it off over to May. Thank you so much.
Hi, thank you. I'll share my screen. I'm actually not sure how I could do this full screen, but I hope this works for everyone.
It looks
Okay.
great.
All right, sounds good. All right, so hi, welcome everyone. I know that a lot of you may not be from U of M, so welcome to U of M. I'm also happy that each and every one of you get to experience different fields of science and STEM laboratory experiences this summer. So our project is called Designing for Planned Obsolescence and Reconstruction through CO2 sequestration and mineralization. And I'm a faculty in College of Design in the Department of Architecture, Landscape, and Interior Design. And we actually have two other mentors who are from College of Science and Engineering, and they are from the Department of Earth and Environmental Science. They'll introduce them on our next slide. So this is the flow of our presentation. We'll do a brief intro of the mentors, and we'll go over why this project is important. So project justification. And then David will explain a little bit about the scientific background behind our experiments. And then we'll talk about our research activities and the timeline over the summer, and then end with the Q&A session. So this project is a collaboration between Earth and Environmental Science and Architecture, Landscape, and Interior Design. Dr. Peter King is an associate professor in Earth and Environmental Science. His research area is in, so he's a professor in hydrogeology, and he mainly looks at flow through fractured and porous media. And David, do you want to go over about your research area?
Hi, my name is David. I'm currently a postdoc researcher in Earth and Environment Sciences, and my supervisor is Peter Kang. And my research focuses on the processes of mineral dissolution and precipitation, ranging from pore scale to atomic scale. And additionally, I also explores a physical chemical effects of fungi in the subsurface and aiming to understand their impact in our environment and how to engineer the system. So I'm very excited to build a new research with you guys.
Thank you. And David also recently moved from UT Austin, so he hasn't really experienced the full breadth of our winter in Minnesota. So if you get to work with David, please let him know about all the good things about the winter here in Minnesota. So my name is May Hwang. My legal name is Sun Min. I go by May. My research area is mainly twofold. First is in physical and seeing how physical design factors influence our human behavior. And it's particularly focused on our eating environment and how the physical elements around us can shape us toward having a healthier eating habit, and also so that people waste less of the natural resources we have around us. And that leads to my second main thread of research, which is in environmental sustainability. So in looking at this, I look at waste streams. I'm very interested in waste in general. And I look at circular economy, meaning how do we recycle and reprocess material so that it doesn't go to landfill, but gets reused again so that it has a closed loop circular economy. And I also look at material innovation, but so not so much from a scientific perspective or laboratory experiences, but more from architectural and our needs perspective. And you'll know what I mean when you get to the end of this presentation. So those are areas that I focus my research on. So our goal for this project is to have a truly interdisciplinary way of collaborating and coming up with a sustainable built environment. So going over why our project is important. The built environment is responsible for about 42% of annual global CO2 emissions. And of those total emissions, building operations are responsible for approximately 27% annually, while the embodied carbon of just four building and infrastructure materials, which are cement, iron, steel, and aluminum, they are responsible for an additional 15%. And we will be looking and tackling closely, particularly in this area of building material of cement, how we could have an impact through material innovation and use in this area. And the reason for our focus on cement is because it's one of the highest impact material that are 100% used to build built environments, such as buildings. So it is of utmost importance for builders and architects to find and replace the use of such materials, right? Or find an environmental use of these cement, either use less or find an alternative for it. And to provide a bit of a background of cement, cement is an important component of concrete. And concrete is a composite material that is second most used substance in the world after water. So you can start to imagine its magnitude. And is the most widely used building material. In fact, concrete uses twice that of steel, wool, plastic, and aluminum all combined. In concrete, the key ingredient material is called cement, and approximately 5 to 7% of greenhouse gas emission come from cement alone. And concrete, due to its cement content, even though it may not be high in ratio, cement or concrete is the largest contributor to embodied carbon in our built environment. And the cement is actually produced by burning limestone at a very high temperature, as high as 2700 Fahrenheit degree. And thus this process not only consumes a large amount of energy itself because of the heat gone into producing it, but it also releases a huge amount of carbon dioxide from the combustion. So what can we do? What can we do as scientists, environmental scientists and architects? From the scientific perspective, we are actually working on it pretty well. We're on a good path. There are lots of ways to reduce carbon impact of the individual components and processes. And there are three key areas to how it's being developed. So first is using low carbon fuels. So instead of coal, we may use renewable natural gases, such as waste fuels. And second way is to use low carbon blended cement. Mixing cement with biochar is also known to improve its structural stability and its strength. We can also mix it up with fly ash, which is a byproduct of coal-fired power generation. We can also mix it up with slag, which is a byproduct of iron manufacturing. And as a whole, they can reduce carbon footprint by 10 to 20%. And the third way is carbon capture. And And that can capture 100% of carbon emissions from cement manufacturing. And our focus on our project would be on number 3, the carbon capturing process, and a bit of number 2, using biochar mixed with cement, but that's only to see a better effect of number 3, carbon capturing. So then what is carbon capturing concrete then? Carbon concrete can be used in multiple other terms. So the terms that you see here are all interchangeable to some extent. Carbon concrete, lower carbon concrete, decarbonizing concrete, buildings that soak up carbon, embodied carbon in construction, carbon neutrality. They're all terms that you would start to see once you dive into this project. So carbon mineralization is a method of carbon capturing, utilization, and storage. And it's often abbreviated as CCUS. Carbon dioxide is injected into fresh concrete while it's being mixed. And when it's being injected, a chemical reaction takes place between calcium oxide in the product cement and the carbon dioxide. And this reaction creates nano calcium carbonate, CaCO3 minerals that become permanently embedded. So not only does it capture CO2, which is a culprit of global warming, but it also provides an opportunity for concrete to self-heal by creating a new form of cement in the form of mineralization. And that's why this method is used frequently in historical buildings where natural restoration is needed. A few examples that utilize this concrete can be seen nowadays in modern buildings as well. And the high-rise building in Chicago, developed by Sterling Bay and Maglan Development Group, is also one example. The Amazon headquarters in Arlington is another. And these examples all contribute to 20% reduction in carbon footprint compared to the industry's baseline. And another example that nicely segues into the architecture realm is this cube building in Germany. And it's used as a lab and an event space for the university campus. It's designed by German architect 10, and it's in the Technical University of Dresden. It is one of the first carbon concrete buildings, a form of carbon concrete reinforced with new material that was tested with carbon fiber instead of steel. So instead of using steel, this has an embedded feature of strengthening itself in and out of itself. And that allows a thin twisting facade, which is the outer layer of the building that references textile-like quality of carbon fiber. And it's also lighter and stronger than traditional concrete, hence allowing it to not corrode like other buildings do. And it's not quite exactly the same as the previous examples that we have seen, but because it has another layer of that carbon fiber strengthening quality, which is another layer of innovation that's added onto this. But what's important about this project is that it's unique in that this carbon captured concrete led to an innovation that informs the form of the building. So it's not only about the environmental aspect, but it's about how it has led to this new form of design. So in a way, in a nicely way, if you put in a nice word, it is a project that embodies a way for the future of design, truly marrying environmental responsibility with newfound formal freedom. So this is actually our main goal for the project. So we may be doing initial phases of concrete studies, but we want this project to lead to something like this. And we as human race are actively seeking scalable and environmentally friendly concrete solutions. The University of Colorado is developing algae concrete, and that's because algae has a function where it can precipitate the production of limestone through the algae's photosynthesis. So there's a lot of cutting edge research being done in this area. So then what's holding back architecture industry? Why can't we just use these really environmentally friendly concrete? Well, it's a new material. So compared to concrete, which has been around since BC, 6,500 BC. So concrete has a long history of its use. And so with this new material, we don't know how long it will hold up to. And there's a risk involved in that. So, and also because of the research that has gone into this, it's more expensive than traditional material. And it's only, at least for now, it's only available in precast parts, meaning it has to be done prior to the building. Or it can't be done as the building is being built. And not all buildings have this, are built with the precast parts. So a new way of building construction method or a new way of thinking about building sustainability is really needed urgently and should be considered simultaneously with all these concrete studies. So what we need from an architectural perspective is not to be really passive about the way we respond to material innovation. We can feed into and we can grab those materials. But at the same time, we can rather be proactive in thinking about building sustainability in a completely different perspective, so to speak, in a more radical way, so that we can truly start to move forward to a more sustainable solution. And this is one example that will show you what I mean by this. This project called the Salt House Project started out by questioning the notion of building sustainability. As creators and designers, we tend to want to design for perpetuity. However, the fact is that anything we make becomes old, and someday it breaks, it shows wears and tears, and it eventually becomes useless. The design industry has sought many ways in which our design can be manufactured and constructed in a sustainable way. One way is to recycle materials, so grabbing materials from abandoned sites. And the second way is to reprocess materials, so grabbing those aggregates of cement and asphalt, and then reverting it into something else that could be used. The industry has looked closely, particularly in ways in which material can be recycled, reused, and reprocessed so that we can extend its use of service. So the left upper corner, you see a capsule hotel. It's a reconfigurable unit. So the idea was that if one unit doesn't work, you would just replace that part. On the right upper hand side, you see container boxes turned into retail, or you can even see turned into residential purposes. So these are all ways you are reusing materials and kind of wanting to extend its life use. However, if you think about it, they're actually not that sustainable as you think. So the capsule hotel turned out to be a failure because of the idiosyncratic shape, but also because, you can't find parts that are 50 years old, or no one's gonna take that effort to come up with a customized part. Also, in container boxes, in order to revert that into something that you can occupy, there are more energy that are going into reverting it. And so it could be more environmentally harmful than to be friendly. So the project that the Salt House project rethinks the notion of building or design sustainability in a completely different way. Before we jump into the details of the project, if you look at this diagram, yeah, we notice that we rarely abandon a building because it's too dilapidated or it's not useful. So most buildings become old and not used not necessarily because of physical parts, but because the building simply goes out of style or some parts get dysfunctional. Also, building parts all have their own life expectancy, so they don't all line up together to get old at the same time. So that was also another problem. There's a discrepancy in the longevity of each parts. Now, if you look at this diagram, you also notice that building components far exceed the actual lifespan of buildings. So schools in the 80s don't look the same as school nowadays. The way we are educating children change over time. Hospital waiting areas also look different. Residential styles also change over time. And so we're instead of wanting a building that lasts forever, although we have that assumption, we're almost actually forcing its retirement. So what we can start to reimagine is a project like this, the Salt House project. This project tests a radically rapid turnover of the building's life cycle. So for example, we could design a building in a place like the island of Galapagos, Ecuador, which is one of the most ecologically sensitive sites on Earth. So we wouldn't want to do any form of encroachment of any type in a site like this. In this project, sustainability is realized by designing salt-cured seasonal residents, which will gradually and naturally be demolished over a designated period of time. So the big picture is that the house will evolve and decay over time, varying not only in its form, but also in its function. So when it's at its initial stage, it'll be more enclosed. So it'll be used for private services, whereas if it moves towards its end of its life cycle, or when it's closer to its death, then it could be used as a public space, as it will be more open. And as a natural consequence of these concepts, all building materials in this project are going to be based on natural resources available from the site, including salt, soil, gravels, and coconut fibers. And water and heat will be the binding solution of the building structure, while wind and rain will act as demolition agents. So it is a project that challenges the field's focus on reducing building obsolescence over time by reversely mandating a building's life expectancy to be as ephemeral as possible. So these are some of the material tests that was done for the project. On the upper left corner, you see the degradation processes in different material types. And the right upper hand image is examining how material degrades under simulated rainwater. And the lower image shows different forms of building structures that comes out as a consequence of this concept. So this project is a way of seeing how the two environmental sustainability and sciences and the needs of the architecture and kind of rethinking this whole notion of sustainability really comes together to create a truly sustainable built environment in an ideal world. And as mentioned earlier, we want a project that embodies a way for the future of design, truly marrying environmental sustainability with newfound formal freedom. So our project will be envisioning the future of building construction through this new material. And it has two aspects to it. So first, we want to be able to see the degradation of the material, and we want to see the mineralization process of it. And the objective is to prototype carbon capturing building material at a tangible and visible scale, to examine its degradation and mineralization process. So we need to understand the science behind the prototyping of experiments, and David will go over this. David?
Thank you, May. Yeah.
Mhm.
Okay, so let's talk a little bit more about the science and mechanism behind this carbon mineralization and also deformation of the cement. So let's first talk about the CO2. So we extract oil from the subsurface, right? And the fuel, we usually burn it for the cars and for to generate electricity. And during that process, the energy of carbon decrease about like 400 kilojoules per mole, and we make a CO2. But the problem is CO2 is a greenhouse gas, and that increases the temperature by 2 degrees C on Earth, and that has been a problematic. And I personally experienced in the Minnesota here, even though I've been just like 4 months here, but I've never seen snow yet, and this is problematic. And globally, like people and all the industry is trying to they are trying to put some effort to reducing emission of CO2 or capture CO2 from the air and make it into a mineral. Then why do we need to make a mineral with CO2? Because we can reduce the energy of CO2 but if we mineralize it, which means it's more stable and it will not go somewhere else and it will not evaporate and go back to the air again. So it is a kind of a permanent a way of storing a CO2. So the carbonate mineral, maybe you guys must be familiar with calcite. If you go to the caverns and people, the guides will explain, oh, this cavern is made out of the carbonate mineral, which is calcite, aragonite, and that looks like the picture on the right side is like transparent minerals. So our goal is to make our building materials new building materials that is degradable, and eventually we want to turn everything into those carbonate minerals. Can you go to the next slide? So how things are working. People in geological carbon sequestration area or carbon capture area, they use similar chemistry. So we need a certain alkaline mineral so within the rocks. And if we react that with CO2, then we can make a carbonate minerals. But not all minerals are working. So they said it's a certain alkaline minerals. What does that mean? We need a divalent cation, and the counter anion should increase the pH of the water. So that's the minimum requirement for this reactions to occur. So the representative minerals will be like mafic rocks or ultramafic rocks, and those are naturally existing materials, but we are focusing on the construction materials. And thankfully, the cement itself is a really good alkaline minerals. So can you go another slide? Yeah. So cement does have, cement is a really complex material, but there is a material called calcium hydroxide, and people say it's a portlandite. And once it is dissolved, it produces calcium ion and two hydroxyl ion. So hydroxyl ion increases pH, and we have a source cations there. And if you look at the SEM image, that's a maybe I think it was 64,000 times zoomed in image of the cement surface. And if you can see that hexagonal plate there, and that's a portlandite. This is a reactive species in the cement. And also we use a water that has been pressurized with CO2. So on the right side, there's a chemical equation. If CO2 reacts with water, then it forms a carbonic acid, H2CO3. And H2CO3 is a weak acid, so we can release one proton and another proton. So eventually we can form a carbonate, CO3 2 minus. So on the left side, we have a calcium, and from the CO2, we got carbonate. And if these two reacts, then it will form a carbonate mineral, and the carbonate mineral will look like the SEM image on the right bottom. So the entire process will be a changing that hexagonal plate material into the rhombohedral minerals. So how are we gonna test this? So we first gonna make a new cement blocks, and we'll go through a weathering process, and this will be a raining situation. So we'll build our own material and make a block and put it in the rainmaker in the Safo, and we'll start to rain and make a rain with the carbonated water. So the carbonated water is, you can easily think it as a LaCroix. So there's a lot of carbon dioxide dissolved in there. As soon as it reacts with the cement materials, it will start to dissolve cement and make a precipitation. And then in the entire process will be imaged with a camera and also a laser scanner so that we can see the deformation of the surface and also color changes. So we are planning to make around 5 samples. The first will be a mixture of cement and the quicklime. So here we need to give, here I will need to give you some more background here. So portlandite or Portland cement itself is a really good building material, and it has been used a lot. And you know, it is not very dissolving. It is all your, even your house, the base is made out of the concrete, and it's not dissolving that fast, but we need something deformable. So we want to increase the portion of a portlandite, which was calcium hydroxide, and the way we'll be adding a quicklime more into this cement paste. So we can add more, we can vary the ratio between Portland cement and quicklime, and we're gonna test 8:2 or 50:50 or 20:80 ratio, so that we can kind of quantify how fast this is deforming if we increase the calcium hydroxide content. And another one will be a gypsum. Gypsum is also a good material for building, interior building, or for art purposes. And this is also very reactive, and also that gypsum can release calcium, so we can go through the carbon mineralization. And lastly, we will test the cement with a biochar. So biochar does have an effect to increase the strength of the cement, but also biochar has a really high surface area so that it can capture CO2 as it is with a in the gas phase. And also in those minerals can grow inside the pores, so that's a really good conduit for those minerals to grow. So our goal is to test these three big materials in the rain, and we'll try to dissolve that in the rainmaker. You're muted. You're still muted, May. Sorry.
Oh, sorry about that. Thank you. So, thank you, David. Going over research activities, we have three main methods. And for method 2 and 3, I guess we wouldn't need to have that much of variable. So we'll have maybe one of each. So one for gypsum and one for cement biochar, but we'll make that into two versions, one just with fully filled, and one with more porous block. And for number 1 option, we will vary the ratio. So in total, we'll have 10 for the regular mold and about 10 blocks of prototypes for the porous mold. So about 20, we'll be testing with 20 blocks. And at the moment, we're thinking maybe somewhere between 3 by 3 by 3 inch block or 6 by 6 by 6 inch block. And yeah, and then as David mentioned, we'll take it to a laboratory to test it under rainwater, simulated rainwater. And the skills needed for this project are, or skills that you will learn from this project is fabrication skills, which are what architecture field requires and does a lot on. And so, yeah, and then so we'll be working in the College of Design side for this. And then image processing to process the images of the degradation. And you'll also be exposed to script writing and coding, which both of imaging and script coding pertains to computer science skills. I know that a few of you have computer science background. And so you'll be exposed a whole range of array if you come to this project. So as for research sites, we'll be working in 3 different locations, and they're actually the first 2, the fabrication shop and John Tate Hall, which is where David and Peter's office is fairly close to each other. They're just right across the street. And these are the 2 main sites you'll be working on. And then for CO2 infused rainwater simulation, you'll be working at Safo, which is a bit distant from the rest of the 2, but it's really located in a beautiful location within the city. Okay, so this is our timeline. For the first week, we'll create molds and pour our mix into the molds. And then second week, we'll be working with rainwater simulator. Third week, it'll be mostly image processing. And then I know I'm being ambitious, but I hope to do a second round of prototyping because these type of things are all about iterations after iterations. But it's okay if we don't get to it, but if we do, then that would be great. And then the last week will be dedicated to visualization, reporting, and prepping for the presentation. And this will be available in Google as a shared link. So we will be adjusting it based on our schedule. And so this is tentative, but it will be shared with all of you guys. All right, so we'll end with a Q&A session. Any questions? Thank you.
That's amazing. I really appreciated you putting like a working schedule for the students to kind of visualize what they would be doing. That's super helpful.
Thank you. Yeah, that's great.
Students, do you have questions?
I have a question, but I wonder, does it have to be about the project, the research project?
What's your question?
I was just asking about I guess like just background information, or not information, but questions. When I was looking at the work that you've done, some questions came up, but it wasn't really about like this, I
Oh, that's
guess.
fine. If it's
Okay.
related to May's work, absolutely.
Okay, great. So I guess my first question is, what fueled your passion for environmental issues?
Okay, that's a great question. So what field of environmental design do I have passion for? Is that the question?
Yeah, like what inspired you to work on and help solve environmental issues? Yeah.
Yeah, sure. Yeah, so I have a background in, actually, I have a degree in uh multiple areas. So I have a undergraduate degree in interior design and housing, and then I have a master of architecture from MIT. And then my PhD was on human factors and ergonomics from U of M. And so when you first think about design, and most people, when they think of a design, they tend to think that it's all about aesthetics and it's all about putting things together in a pretty way. And that's a misnomer. That's a misunderstanding. And I was exposed to a series of projects that engaged me in projects that had more impact to the people and to the environment. So so for example, Habitat for Humanity is a wonderful way, which you might all know. It's housing for affordable, it's an affordable housing for, population who may not be able to afford housings. And I also went on a trip to El Salvador to see how a community that was displaced by an earthquake could revitalize itself and have a long sustaining community within itself, even though it was disrupted. I guess it's kind of a thing that just you're exposed to little by little, and when you are working on a project, you only want to be involved in projects that has the most impact, because otherwise it would not be meaningful. So you don't want to reinvent the wheel in a way that's just feeding into the wrong problem. And I guess as faculty, that's also my job, to be thinking about where the industry is headed and how we can have a positive impact. So it's a long, yeah, it's a long answer short. You just have to be continuously exposed to it in order to have this long lasting interest. So I hope you get to choose this project because it'll also give you an opportunity to think about how whichever field you may end up in, how you can have an impact in your field. Hope this answers your question.
Yeah, it did. Thank you.
Yeah, sure. Welcome.
Elena, did you have another question or?
Yeah. My next question is about how do you think your experiences abroad affect your current career now?
How did my experience abroad, and you mean internationally,
Yeah.
affect where I am now or what I do now?
How did because I've seen that you have worked in different places abroad, and so I was curious as to how that kind of shift your view for your career, or if it did in any way.
Yeah. So I was actually, not only in terms of work was I exposed to different works, different cultures, but growing up, actually, I grew up in several different countries, including Japan, Panama, Indonesia, and I studied abroad in Spain. So I truly consider myself a motley identity person. Um, and I think, and not all people who were exposed have the same interest. But I think what really affected my research interest and career is kind of being in other people's shoes, having that different perspective, really kind of allowed me to also going back to your former question, like what is the impact? What's meaningful and how can I have an impact? Is this really meaningful? I think that's a constant question I ask myself. And that's why I try to seek, research projects that could potentially have a positive impact, not only for myself, but for people around. I think that's kind of a common goal for most researchers, though. So I don't know if I'm speaking for myself, but I feel like this is a general, goal for most researchers, at least in my university. So I don't know. That's also a long story short. My short question answer.
Yeah, thank you.
Thank you.
That's great. I like that you had that background information and we're wondering how that influenced her path. Oh. Any other questions? I have a general question and this might be directed towards David. You hear about carbon selling carbon. So if you have a lot of land or different things, so like carbon offset, what are your thoughts on that?
Oh, it's more like a kind of policy stuff. It's not a science wise, but
No, I
yeah,
know, but
yeah.
I'm interested in your opinion, knowing more about that area and knowing more than I do. It just seems odd to me, and I've always wanted to ask somebody, and you were the first person I've come across since I've learned about it that would have kind of a background.
Yeah, I mean, like buying it or selling the carbon for, and like many industries does that. Like for
Yeah.
example, in the oil and gas industry has to pay for the carbon emission a lot because they are a major source of the carbon producing companies. And I also thought it is like weird to make into like money wise approach,
Yeah.
but I think in like in government policy and everything, we rule everything by money. So I think that's the only way we can control and force people to do it. I mean, we all care about the environment, but not all people really active on it, active. And the way we can engage all the citizens to take care of the environment is putting them a obligation in terms of money. That's the best way of how that's the best way how the environmental policies have been evolved. So I know it's a really not a good idea to change CO2 into money, but I think otherwise it will not be very effective.
Yeah, I was just wondering how helpful that is.
Yeah.
But thank you.
Yeah.
All right. Any other questions? Well, I want to thank David and May for giving us their time. And I appreciate that timeline that you provided for the students. That is helpful. And yeah, I'm excited. I'm not in that area, but it looks exciting.
Yeah, we're also very excited too.
Good.
And that schedule also helps us also plan it out. We purchase materials. So we didn't want any delays because of material not arriving. So yeah, it also helps both sides.
Yeah.
Thanks for having us today.
Yeah. Thank you. All right. We'll let you guys go. I'm going to keep the students on. We'll take a 5-minute coffee break and then students will stay on with me and I will go over kind of developing a research plan. Sound good?
Yeah.
Okay. All right. So let's call it 11 o'clock on the dot. All right. All right. Liz, take it away.
Okay, hopefully everybody's back. I'm going to start just by sharing my screen. I have an announcement about the schedule. Okay. Great. So as we wrap up week 1 and we start to think about week 2, I just wanted to clarify a couple of things for everybody. So on Friday, which I can't believe is tomorrow already. So on Friday, after we hear from Dr. McGovern, hopefully we'll finish that around 11. We'll ask you to fill out a Google form, which will rank your preferences of faculty that you've heard from this week. And so what you notice on the tentative schedule is that we've tried to designate Monday and Wednesdays as lab skills days, Tuesdays and Thursdays for your research project, and Fridays for professional development. Now, as a reminder, the time commitment for the program is 20 hours per week. The 3 hours that we've blocked off for each day of the week only add up to 15. So that leaves 5 additional hours of flex time. So on days where there's nothing scheduled, so for example, Tuesday, June 18th, we don't have any time here, right? This is based on your schedule. You have the ability to use the hours to your discretion and based on your schedule. So that includes Monday. So Monday we meet from 9 to noon. If you're available after that to go to your research lab, you're welcome to do so. We just don't want you to go over the 20-hour time commitment. That's not equitable or fair to you. So we want to be respectful of your time. So, keeping that in mind, let me pull up the Google form. Okay, so this is what the Google form is going to look like on Friday. If you notice that Dr. Yang will have a maximum group size of 2 students, but the other faculty don't have a restriction. So ideally, you will be with a group of your peers working in these labs. So we're going to ask you further down to indicate what times in general you're available to go to the research lab each week. So for week 2, it might be really helpful if you have the Google Calendar or the Excel spreadsheet open to see the schedule. So for next week, Monday afternoon is from 1 to 6 p.m. This is in general as a maximum of 5 hours. It's from 1 to 6 p.m., right? Because we have lab skills from 9 to noon. However, on Tuesdays, there are 2 time blocks, potentially in the morning from 8 a.m. to 1 p.m., or in the afternoon from 1 p.m. to 6 p.m. These, keep in mind again, these are just the maximum time commitments for these days. You do not have to be there for 5 hours. And so on and so forth. So I tried to match what you were doing, what's already predetermined in the schedule, to give you options based on your schedule to go to research lab. That was a lot of information. Is anything unclear or confusing? Please feel free to unmute and we can talk about it.
So that means we have the option to go to labs on the days that aren't designated for labs?
That is correct. Yes, Chris. So on days that are not specifically designated research days in the calendar, as long as it's after our scheduled meetings, yes, you can go to the research lab. So that's why I did include that as an option in the Google form. Does that make sense?
Yes, but then does that mean that we have to go to the, yes, required days too?
That's right. So for example, sorry, let me see. I've got so many tabs open.
We're not asking for additional time. Let's clarify that.
Yeah,
Right.
we're definitely.
So if you spend 3 hours instead of doing it on a Tuesday and you spend it on a Wednesday afternoon, you don't have to spend that lab time. But it is in addition to lab skills and professional development.
Yeah, so for example, let's say on Monday the 17th, you're going to the lab skills from 9 a.m. to noon. Let's say you cannot go to the research lab on Tuesday the 18th, like you're not available at all. And instead, you're going to use your afternoon on Monday the 17th to go to research lab. That's perfectly fine. So then you're not expected, right, to go to the research lab on Tuesday because you've already put in those hours on Monday. So you're free to use these days where there aren't scheduled times at your discretion.
I suppose we talk to whoever the researcher is that we're with to discuss when we're going to be there. And
Yes, absolutely. That's correct. So that's why I have, I have that question in the Google form so that when we connect you with your faculty, I will also share with them your general availability. Does
So
that
yeah, so we check in with our mentor when we get there, and they observe us.
Yeah, so when you get there with your mentor, they will be telling you what you're going to do, right? So they're not going to let you come to lab and just not give you any instruction, right? So the person that you're reporting to on your research day is going to give you instruction on what you're going to be doing. Um, and so that's why we're finalizing these details on Friday, so that way you will know exactly what you're going to be doing next week. So, Rihanna, I see your question in the chat. How many days are we expected to be in the lab? So, based on what we have planned each week, there are a minimum of 6 hours of research hours that we've built into the schedule. You can see the 2.5 hours of flex time. So there's a maximum then of about 10 hours, 10.5 hours of research hours. For simplicity, we designated Tuesdays and Thursdays on research day, but we do not, based on other people's schedules, we're seeing that that's not the case for everybody. So if you think of it in terms of minimum and maximum hours for research, that might be more helpful rather than the number of days.
Rayon, did that answer your question?
Yeah, that made sense. Thank you.
All right, other questions? I will note that Liz has far fewer tabs open than I do.
I was wondering, so the maximum is 20 hours. in the case that they're like that we to go over that, or like ever is
I would say that you
like,
are welcome
I
to put as much time as you want into this experience and get as much as you can out of this experience. However, you won't be compensated for anything more than the stipend. Does that?
yeah, that makes sense.
Yeah, that's a good way to put it. So again, just reiterating that there are certain things planned each week that have a designated time that are part of your 20 hours a week. That for week 2 includes Monday in person from 9 a.m. to noon. That also includes Friday. It's virtual, but it's from 9 a.m. to noon. The remaining 14 hours that will be dedicated to your research will be available to you based on your schedule for purposes of a schedule for the program. We just designated them on Tuesdays and Thursdays. Does that help at all? If it doesn't help, please speak up because we want to make sure that this is clear.
Yeah, it's clear.
Okay. Okay, well,
All right, thanks, Liz.
anything comes up, you have my email address.
Sounds
Okay.
great.
I'll stop bothering you now with scheduling.
No bother. It always helps to make sure that we're all on the same page and what's expected.
I think everybody will feel better once they know what labs they're going to be working in. So,
Yeah. Well, hopefully by tomorrow afternoon, you guys will know.
yes.
All right.
All right. Have a good day, everyone. I'm going to hop off, but I'll be around.
Okay.
Bye.
All right. So I have a lot going on here. Probably shouldn't have shared all that. All right. Research elements we went over yesterday. Research plan development. All right. So we're going to look at developing a research plan. Most of what I have here was taken from a 6-step process to developing an educational research plan. I know that you don't really want to do worksheets, right? You want to get into kind of doing those kind of things. These are meant to be step by step, just so you don't forget a step while you're learning the process. So before conducting any research, you should develop a research plan. It should include the overall purpose of the research and how it's going to be used, the typical sources of data, including primary and secondary sources, the means by which the data is collected. Knowing how you're going to analyze the data helps with planning how you're going to do the experiment to get the data, right? Because you want to make sure that those align so that, because your data collection might be just a snapshot. You might only get one shot to like get a whole bunch of data. And if you're not getting the right data, you've now wasted a lot of time and effort. Means by which the data will be collected, the scale of the research, how big is your experiment? Typically in this situation, you're going to start as like a small part of a larger experiment, right? You're going to be contributing to kind of a larger experiment. What are the resources available? In planning a lab, you have to think about what you have, what types of equipment. I know that when we were planning on introducing undergraduate research into our teaching labs, we needed to make sure we had and we wanted to do PCR, we wanted to do gel, we had to make sure that we had thermocyclers, that we had a -70 freezer, that we had all of the equipment needed. And sometimes that can include funding, but resources also include time. How much time is it going to take you for you to plan that experiment or complete that experiment, and a clear indication of the stakeholders in the process. All right. So we're going to look at a stepwise process to developing an educational research plan. We're going to identify the problem, review the literature, specify a research purpose, and design a study. All right. So let's look at identifying the problem. All right. What is the area or topic of your course, clerkship, clinical setting, wherever your research is? So, and I'll give an example in the next slide. What is the educational research problem for this study? Why is this topic so important to study? And do you kind of see with the 3 questions, they sound very similar, but they are looking at different things. In the question 1, they're looking at a general area, like being more broad. Educational research problem, that's a specific question. Why is this topic important to study? You want justification. Who's the target audience most interested? Is it clinicians? Is it other researchers? Is it industry? And then should the problem be researched? Right? Does it fill a gap or void in the literature? Does your problem replicate a past study? Does the problem extend past research or examines the topic in a more thorough manner? Does your problem give a voice to people that are silenced, not heard, or rejected? Does the problem inform practice? All right. So let's look at, we heard from Dr. Keller Ross yesterday. So if we look at that first question, and I basically just kind of looked at it as, okay, what is the area of topic or concern in this course, clerkship, clinical setting, research project? In general, her topic area is cardiovascular disease and hypertension risk in menopausal females, right? That was kind of what I got over that. What is the research problem for this study? Increased morbidity of cardiovascular events in menopausal women. And so we want to look at that a little bit closer. Why is this topic important to study? It is the leading cause of death in women, right? That was what she started with. And when you look at your papers, the introductions, it asks you to tell you, why are you studying this? Why is this important to know? Why do we need this information? And when you're presenting, it's the same thing. You want to know right away, why am I listening to this? Or why am I reading this? Who's the target audience? For hers, I thought maybe clinicians, other researchers may be the target audience, because it could possibly change policy. I gave there's an example of, they've changed the clinical guidelines of hypertension, over the years. It used to be at 140 for systolic. Now it's down to 130, right? So anything above 130 is now considered hypertension, whereas 10 years ago, you were still fine if you were in the 130s. Should this problem be researched? So does this fill a gap or void in the literature? I would say yes. They have a lot of data on men. They had a lot of data on early development in women and postmenopausal, but kind of not really that menopausal section. Does your problem replicate a past study? No. Does the problem extend past the research or examine more topic more thoroughly? Yes. It's building on previous research. Does your problem give a voice to people silenced or rejected? You can answer this either way. There is something to be said about different populations being not included in some of those earlier research studies. So a lot of the data that we have, what's the normal range is for a white male about this weight. And so it may not translate to the population that we're looking at. Does the problem inform practice? Right. And this is where, this work could inform guidelines of You know, if you have a patient that's perimenopausal or menopausal, do you need to adjust the threshold at which you're looking at hypertension or looking at addressing hypertension? All right. Once you kind of got that problem, why are you looking at it? What the problem is? Okay, then you start reviewing the literature. And we went over kind of all of those databases. I have talked in detail about it, so I won't go over that too much. But identify key terms, right? You want the term. So in this case, it was hypertension, menopausal, um, cardiac events. I mean, those are the types of terms that you're going to look for. Topic areas, you want 2 or 3 keywords, and then don't forget to think about, is this termed differently in different fields? So a cardiology researcher might look a little bit different than an OBGYN who's also dealing with perimenopausal women. They might use different terms in their field of practice. In which case, then you want to know if there's synonyms or words that kind of mean the same thing. Devin's laughing at me because I couldn't pronounce synonyms and I kept saying synonym. All right, well, we're going to just move past that. Locate the literature, consult several databases. So even if you're using Google Scholar, maybe go into something that's more specific to what you're looking at. If you work with May and you may need to look at a database, ask her about recommended databases for that type of work. PubMed is not usually that helpful for environmental science or carbon dioxide sequestration, right? You're not going to find a lot unless it's related to a medical in PubMed, but you might in some of those engineering websites. So talk to your research advisor or your mentor about what types of databases should I be looking in. Critically evaluate the selected literature, right? Note first if it's a primary or a secondary source. I think secondary sources, reviews, meta-analysis, and stuff like that is great for kind of giving you an overall picture of what the field is like right now. However, when you are doing the research and you're going to be writing the articles and things like that, you want to kind of gear towards more of the primary sources. You might miss some of the nuances in the protocol, the design of the study, different things like that if you're reading a secondary source. Organize the literature by dividing into broad categories. Okay, this group suggests a diagram or outline of the literature review. I'll give you an example of kind of what that looks like. All right, so the big questions. What are several key terms regarding your problem? Which databases are you going to use? What types of sources did you locate? Primary, secondary, and then create a literature map. So let's use it in that example. Key terms for Dr. Keller Ross's research was, I put in menopause, female, hypertension, autonomic was another thing that she talked about quite frequently. What databases? For hers, I would use PubMed and Google Scholar. That would be my first 2 go-to. Still talk to the research mentor. There might be some clinical databases that I'm not aware of, or they might have access to. What types of sources? Again, you want mainly primary sources. I looked up kind of, 2 of her articles. One was a secondary source and one was a primary source. And then create a literature map. I don't know if any of you guys have done like concept maps, like what's the bigger concept? And so in that center where you're understanding, in this case, they're saying is understanding graphs, you might put hypertension in menopausal women. And then you can branch out from there. They kind of keep it organized into categories. You do not have to put it into a diagram. For me, I find that helpful. Like that other exercise that we did yesterday, where I said I was having fun putting the terms where they're supposed to be. It forces me to think about it in a different way. How would I categorize or group this? Why would I put this in this category and not this category. So now I'm thinking about how that paper relates to other papers without really it being kind of a chore and without getting lost in it. So I find these concept maps helpful. If nothing else, try it, right? If it doesn't work for you, it does not work for you. Try it, you'll get frustrated, you'll get upset, then leave it for a day. Don't decide if you're not going to use it yet, and then sleep on it, then come back to it and see if you learned something different or that you feel differently towards that. All right. Step 3 is specifying a purpose and a research question. All right. Writing purpose statements, research questions, and hypothesis are provide critical direction to an educational research study. They identify questions that the researcher will answer throughout the data collection process. So the purpose statement provides the overall direction or focus for the educational research study, and then the research question will narrow the purpose. All right. So again, I'm using that same Dr. Keller Ross's example, the purpose of this study, and these are my words, not hers, is a better understanding of hot flush physiology and VMS contributions to CVD or cardiovascular disease. All right. What are the research questions are you seeking to answer? And I took these from her secondary paper. Like this is what she was asking at the introduction of her secondary paper. This is how I found a lot of this quickly. What is the relationship between VMS and CVD? What are the mechanisms of hot flushes and their potential actions on short and long-term blood pressure regulation? How does this disruption of autonomic function associated with VMS might provide a mechanistic pathway to cardiovascular disease development? Right? Those are much more specific questions than just understanding hot flush physiology. All right. Once you get those specific questions, and I would advise you to talk to your research mentor. Like, what would you, and you can ask them, what would you say the specific question I'm trying to answer with this experiment is, right? And they can provide you with context for your experiment. And that will help you better understand the experiment, why you're doing it, and what data you're going to be collecting after the experiment. All right. In designing a study, you want to look at methodology. We talked yesterday, or, I showed you videos of different types of methodologies. Is it quantitative? Is it qualitative? Is it mixed methods? What are you using to test? Are you using animal or human subjects, right? And if you are, then you have to do some other types of steps associated with that. Who are the participants of this study, or what materials are you working with in this study? This is kind of directed towards more biomedical research, but it can be translated to more general STEM research. What's their data collection plan? If you're using quantitative, qualitative, or mixed methods, what tools are you going to use for analysis? Do you know how to use those tools? Your research mentor might have an idea of how they want it to be analyzed and what they want the data to look like. If you don't know how to use that, tell them, hopefully they can just show you or give you a quick tutorial of like, hey, this is how you do it. And that way you can better understand and be able to help with analysis. All right. I won't go over these, but as this is kind of different strengths of quantitative, qualitative, and mixed methods. It talks a lot about sample size, variables, what type of data collection it is, things like that. This goes over the weaknesses of quantitative, qualitative, and mixed methods. All right. For this, and I will put the worksheet that comes with this, so you guys will have access to it, and it's a editable PDF that you can just go through at the end of that and just you can check things, and even if it just helps you remind, if it's not related to you, don't worry about it. If you're not sure if it's related, then you can ask, right? So which methodology is most appropriate for study? Oh, go back. How did you choose the type of research methodology? Who will the participants be, or what are the materials being used? How participants are going to be selected? And then this gets into a little bit of selection bias. Are you selecting it in a way that's going to provide your research answer without bias, without introducing bias? What instruments, survey tools will you use? What evidence is available to show the instrument or survey tools are reliable? What type of quality control do you have built in? If you're using qualitative methods, are you going to code them? Are going to code themes by hand or use a computer? Different types of what sequence, if you're using a mixed method, what sequence are you doing? Quantitative first? Are you doing qualitative first? Are you doing it at the same time? I liked this table here where they're aligning the research question with the data collection method, the location of data, and then analysis method. And so you've got it all in one line. And so for each experiment, you might have that research question 3 times, but you're going to have 3 different data method collections, right? Where's the data located? I took this to mean as that was part of that data literacy. Do you have a filing naming system, right? I put it in file, for that cold stimulation that Dr. Keller Ross was doing. I put it in this file under this date or whatever. So, you can keep that where it's a quick cheat sheet to remember where everything was. And then what methods were you using to analyze? In analyzing and interpreting data, make sure you organize and clean the data. Analyze data using appropriate quantitative and qualitative analysis. So make sure that the analysis is appropriate for what you're looking to do. If quantitative, determine the p-values, the effect size, and the confidence interval. P-value is the probability value, measures how likely it is that an observed difference between groups is due to chance. Okay. Is this just random, or is this actually caused by the effect that I wanted to? Confidence intervals are the range of the upper and lower samples statistical values that are consistent with the observed data and are likely to contain a population mean. And then effect size is a way to identify the strength of the conclusions about group differences. What are some of the most significant results? So these are questions when you're seeing the data and you're seeing it come up. What are the most significant results? Oh, Ashley, yes. What's up?
How do you determine the p-value?
That is a good question, and I'm not sure if I have the exact answer for you. I would work with your mentor about determining it for your particular experiment.
All right, got it.
Yeah, I'm thinking there's a lot of variables involved, so
Yeah, so I
in some
mean,
cases.
hopefully you'll get some of the general thing that you do with calculating a p-value for just in general, but then, it's going to be specifically tailored to whatever experiment that you're working on. So, my math is not great.
Yeah,
but
so is it like an equation?
it is an equation. So it's like the number of samples, plus or minus whatever divided by, and we can look it up. Let's just look it up.
But do you use all 3 browsers?
Oh yeah, and then I've got other browsers. And then
Oh, wow.
yeah. I
Do you
know.
have a favorite?
I like the Chrome. and I try to use different browsers for work than I do for personal because of the saved, and then I'm not going back and forth between Google Drives. But all right. Let's just look at an image. All right, so the p-value formula is this. Now what the z and the n don't necessarily know.
Yeah, that kind of looks familiar in like statistics.
Yeah. We can just do this.
You
1 minute
have a
long.
proposal, but your manager has so many questions. Uh-oh. Let's try again with Grammarly.
Oh,
First,
maybe
learn
the
how AI
advertisement is
finds
1 minute long.
opportunities to help your
You
idea
could skip the
stand
ad.
out.
Okay, well, we'll mute that while the ad is going on.
You can skip it on the right there.
I'm not seeing skip. Oh, because you're,
It says the skip button and then the play
yeah,
sign.
no, your
Oh yeah, that's too long.
your
I could
face is
just
for
look it
there.
up myself.
Reject or fail to reject the null hypothesis using the p-value method. So let's work on this problem.
Yeah, that's 17
Okay.
minutes, so I could just look it up myself
Okay.
later.
All right.
But yeah, pretty much statistics then.
Yes. All of the p-value, the confidence, and the effect size. If you've ever taken a statistics course, they've had you calculate those. All right. Because I did not, because what you're going to be doing in Dr. Ross's, I don't exactly know, and I don't know how she calculates all of this and what data she uses. I didn't give that as an example. But it is on your worksheet for different things. And then the last step in a research plan development is how are you going to report it out? We know for sure that you guys are going to create a poster and present it at a symposium. If you're going to publish, because we've talked about publishing, you want to define the proposed publication. You construct a 1-page document, make sure you have the theme, the data, and the conclusion. From there, then go to whatever journal you're going to submit to, right? And there's instructions for authors because they will have different formats. They might have the results section at the end, or they might have, instead of using APA, use AMA or MLA. Instead of, you might have a word limit, right? And so you want to know what the instructions for the authors are, which will allow you to, it'll be very, very specific on exactly what format you'll need to submit it in. Be concise, be to the point. Scientific publication, we talked about that yesterday. Scientific writing is different than other types of writing. There are no feelings attached to it. It's very concrete, very concise. So the writing will be a little bit different. Typically, every poster paper will have these typical construction. An abstract, you write that last, right? Because you wanted it basically, a shorter version of the entire paper in that abstract. So everybody knows what they're, you still want why you're studying it, but then you're going through everything very, very quickly. The introduction is really about why are you citing it? What is the previous work? What are you building on? Methods, you need it detailed enough so that somebody can replicate your study. Any science paper out there, I should be able to pick up, look at, and take that exact protocol and put it into my lab and should be able to get the same results. Discussion or the results describe typically this is in graphs, tables, figures. It sounds like in May's lab, you'll be doing some imaging. So you got some cool pictures, right? And then the discussion, where you explain why your data leads you to the conclusions it did. Discuss the strengths of your approach, how it agrees or disagrees with the literature, right? So this is the stuff you bring in back from your introduction, and you're like, you know, even though it said that here, this is consistent with this work, or it's not consistent with this work, and why. Strengths and shortcomings of your approach as well. What do you wish you would have done, right? Do you wish you would have sampled different populations differently? Do you wish that you had a better software for data analysis, or had used something else similar to what a previous work did? So just think about that for the next step. All right. This is the last kind of Zoom lecture I get to give you guys, right? Monday, we're going to be in person and we're going to be doing lab skills, and I'm going to keep you busy. One of the things, the couple takeaways that I want as you kind of get ready to go on to this journey. Remember what's your story? Why are you doing this? What is it going to lead to? What's the story? Keep your end product in mind so that you align what you're doing with your research goal, right? So that you're not missing some steps. And it's exciting because now you're progressing from, you know, sitting in a college classroom, just gaining knowledge, gaining knowledge, gaining knowledge. Now you're going to apply in the real world some of that knowledge. Hopefully you continue to learn. All right. I have a video on tips
One of my tips is definitely just to talk to
tips for future undergraduate researchers. And after this, we will be done for the day, and I'll let you guys take off. I'll send you an email about links, but
one of my tips is definitely just to talk to faculty members. When I first got started, I first started thinking about what I might be interested in sophomore year. And I just talked to like one of my statistics professors, just being like, hey, you know, you're an economics professor. I'm interested in microfinance. Do you know anyone who has an expertise in that or an interest? And she was the one who actually directed me to Dr. Deloach. I've never had him as a professor ever. I probably would have never even met him necessarily. Well, maybe, had she not connected me with him. So I think really just discussing it and talking about it, that'll help you really direct yourself to more specific topic and kind of get you going in the right direction.
oh, sorry, I hit the chat button. Okay.
Especially getting steps, finding a mentor and things like that.
The number one tip I would have is don't be scared. At the beginning, it's going to seem like a huge project. You're going to say,
Okay.
how
I'm not
can I
going to
get this done with
respond
the
to any chats
deadline?
yet.
I don't know what I'm doing. What's a literature review? I've never heard these words before. But at one point, every researcher was in that boat. So don't be scared of the tasks ahead of you. You'll do it before you know what, you'll have this great project, it'll be over, and you'll look back and say, where did the time go? So don't be nervous, don't be scared. The more you look at your research as a project you're doing for yourself and not for grades, not to graduate, not for a program, the more you'll get out of it.
My advice to any student interested in pursuing undergraduate research is, you know, pick a topic that you're passionate about, that you're interested in, like, and I mean genuinely interested in. I know that faculty say that all the time. I was told that a lot, especially my freshman year, and they warned us, if you don't pick a question that you're interested in, by the time you're in your senior year, you're not going to be that attached to your project. You're just going to want to have it be done and over with. And so I listened to the advice I received as a first year and second year, and I love talking about my project. Don't be limited in your first ideas. Because when I originally thought about doing a project, I had a large range of things that I wanted to think about doing, but I decided to look forward and look at the broader scheme and then
go forward from there and figure out what I wanted to do. So rather than just going with the idea of, oh, I want to do a presentation about this artist, I want to do a presentation about art during this time, and then this group of artists, and then this artist.
I also took off some time from the concussion project and looked into what other faculty are doing. I think a lot of people come in, like I did, even though it wasn't research, a lot of people come in knowing I want to research autism and do this. But there's a lot of faculty here who are doing some really great research that even though there might be somebody who's in your area, you might have a better relationship with somebody else. And at our level, it's really about that relationship and working together and kind of developing your skills in general, not necessarily a specific project. You can do that once you get to graduate school or higher levels. So I think looking into research, you really should look at all of your options and try and find somebody who matches up best with you, not necessarily, it doesn't have to be the field you're interested in.
If you have some question that you've been talking to friends about, or if you notice that one of your peers, maybe someone older, is researching something that you're interested in, don't be afraid to also pursue that same line of inquiry, but take it in a different direction. You don't need to feel like you have to come up with something so startlingly original that sort of sets you apart. Research really is a process of building on the work of others. So don't, feel like you can't run with someone else's ideas.
I would tell them not to look at the whole project at once, because when I first started and I was just assisting on research and watching, it seemed so overwhelming. But you do it in such slow steps that first you get all the research, and then you think about the procedure, that as long as you just work on the step that you're on, it doesn't seem like such a large project.
For other students interested in pursuing undergraduate research, I think it's important to know that you are important in the process. When I first started, I was very nervous and I didn't feel like I could really give my input on a lot of ideas because, I'm an undergraduate and I'm working with, a highly known professor, highly respected professor. And as the process went on, I became more comfortable. She would ask me questions and I realized that I really had ideas and my input could make a difference, and it really did matter that we were on the same page instead of just, okay, this is your project. It's more our project.
One of my tips.
All right, I apologize. I was trying to do something, respond to a chat quick, and every time I touched the screen, it would pause. So I have learned my lesson. I do not chat while a video is going on. All right. I just want to say thank you guys for being engaged in these Zoom sessions. I will be there tomorrow for the Zoom talks as well. It'll be on this channel. We'll record them as we do before, and then I will send out emails like I did yesterday for Dr. McGovern and Dr. Judy Yang, so that you guys have links to some of their work. All right. Any questions?
I'm just really excited to do some lab stuff.
Yeah.
What were the different topics? I don't know what the is it PCR?
PCR.
Do you know? I mean, obviously, could you, what's
It's a polymerase chain reaction. So when you do DNA analysis, if you want to amplify the amount of DNA, so in most people are with forensics, they're more familiar with forensics, right? You find one hair follicle at the scene of a crime, that in itself is not enough DNA to do tests on. So PCR allows you to amplify DNA to work with different things. And it's pretty common technique used in molecular biology. So you guys are going to be amplifying DNA.
Okay, thank you.
Yeah. Other questions? I'm going to stop recording for today.